Hi, in this video, I'm going to be talking about logs and natural logs. For starters, if you have something like log times 10 or log times 9, you should keep in mind that log, its subscript is a 10. It's just always there. So if it's not written, it's always imaginary. Even for natural logs, its subscript is the constant e. For, if I remember correctly, is 2.7. So the following image over here has an exponential equation, and it shows you how to convert it to logarithm equations, something you should learn in 10th grade if you haven't already. So this right here shows where y goes, where your exponent goes here, and where your base goes and everything. So to start off, we are going to be starting off in example 1. So we have, let's say, 3 to the power of 5 equals, is it 243? We want to convert this to a logarithm equation. Looking at this, you can say this is equal to log of b, which is your 3, your base, so log of subscript b. So it's part of your log. So I know how to do the subscript on Google Docs, but it takes a lot of time to do it. I'm just going to simply put 3 there. I hope you guys can follow along. I'm just going to put a space just to clarify that. That's like one constant in a way. So log 3 times its y value, which is your exponent. So times it by 243. And it's going to equal 5, which is your exponent. So basically, your exponent is your answer in a log, which kind of makes sense because they're inverses. And your biggest number usually, which is the product of the exponential equation, is what's being multiplied by the base. So let's try another example. Example 2. So we have log of 4, so subscript 4. To clarify, that's one variable, sort of. And then let's say we have 1 to the power of 64. Or no, I mean 1 divided by 64, my bad. 1 divided by 64 equals, let's say, negative 3. We want to convert this into an exponential equation. So this would be, well, your negative 3 is going to be the base. So negative 3. Here, wait, I feel like I messed up somehow. Oh, yes I did, my bad. That's your exponent. See, you always have to keep that in mind, that your base is what your first number would be. So your base would be over here. Compared to this, your 4. So 4 to the power of negative 3. So let's write that in parentheses. Negative 3 equals 164. This is how you would convert. Keep in mind, when you keep on doing this and get practice, you'll be a pro at this. Now, I was talking about natural logs. So example 3, well, kind of an example. So this is just information that you should know, just in case your teacher does test you on this. So log is not the same thing as natural log. When you have an equation and when you're looking for an exponent, you could use it in the same way, but they're not the same thing though. Log is when the subscript is 10, or I have no idea how I did that. Well, so subscript is 10, while in natural log, I mean. Oh, did I do this? Hide. Not realize that. ln your subscript is a constant called e, which you should already have learned if you're learning about natural logs and logs, which is about 2.7, I think. But yeah, you should know that. So let's see. So we have an example. It says use a scientific calculator to find a common logarithm and natural logarithm of a given number. Verify each result by writing and evaluating the approximate exponential expression. So I already have this written down, so I'm not going to use anything with the calculator, but you can totally check your work to see if I'm correct. So we have 0.25, and we want to find its common logarithm, or the regular log base 10, and the natural log of this number. So, hold on. It's the log of 20.25, which is the same log base, the base subscript 10 times 0.25, which is equal to about negative 1.38, whereas ln of 0.25, well, remember, the subscript is e, so a different answer, obviously, which is going to be about negative 0.6. So there's that. And now we're asked to verify each result by writing and evaluating the appropriate exponential expression. So now, based off of this, we have to write an equation, an exponential equation out of these. So you might be asking, how do I write an exponential equation out of ln, or natural log? Well, remember this. Well, actually not remember this. Just keep this in mind. Log base of subscript e is actually the same thing as ln. But we just call it a natural log because we have to. So yeah, log base of e is equal to that. Keep that in mind. So now, let's do this. Log. Let's do this equation. Oh god. I am very tired, you guys. But I am still doing this for you guys, so yeah. So this would be